Welcome again to my tutorial. This question was given to me, okay, by one of my students, okay. We've been trying to work out the value of the radius and also the area of the shaded region. Now we applied a few concepts and we discovered that we're getting 0, okay, and I decided to devise another method in which we can use to calculate the radius and the area of the shaded region. Now, and let's see. Now, if you have any other way you feel a solution can be provided to this question, do well to drop your comments in the comment section, and also share your thoughts on what you think should be a way out, to find out the radius and also the area of the shaded region. Now, let's get into the video. All right, so now this is the question. OPQ is a quadrant of a circle, radius 14 centimeters. So that means the radius of the quadrant, which is the distance from the center of the quadrant to the vertex or to the corner of the quadrant, is 14. So let's say let's write down the given value. So we are giving the radius of the quadrant. So we have radius of the quadrant, okay, to be 14 centimeters. But we are not giving the radius of the inscribed shape, which is the circle. So let's write radius, okay, of the inscribed circle. Radius of the inscribed circle is given to be what? R. That's the radius of the inscribed circle. Now, to be able to calculate this radius, now the method I use is that, now having known that from the center, okay, to the circumference of the inscribed circle is the radius of the inscribed circle. Now, I see where somebody used, the formula connecting the radius of the inscribed circle with the radius of the circumscribed quadrant, which will be R equals to, the radius of the quadrant divided by 2. But that doesn't work. Now, in this case, to find the value of R, now the distance from the center of the inscribed shape, which is the circle, to the center of the bigger circle that forms a quadrant, okay, would be equals to 14 minus R. So we're going to have more like an isosceles equilateral. We're going to have what we call an isosceles right triangle. That is the length. So we're going to have that is the radius. Okay, now the radius. Okay, so that means, like I said, from the center, okay, the distance from the center, okay, the center of the inscribed circle now this is 14 minus R. So we have this distance to be what? 14 minus R. And we have this to be what? A right triangle, because we know that now when a radius is drawn from the center of a circle to pass through the point of contact between the circle and the tangent to the circle, all right, the angle there will be what? 90 degrees. So we have this right triangle, okay? We have this right triangle. That is, we have an isosceles right triangle. So which means the length of this side, we have an isosceles right triangle. We have an isosceles right triangle. This is an isosceles, okay, we have isosceles right triangle. Right triangle. We have an isosceles right triangle. So which means this will be radius, this will be radius. So that is because if I drop a line, from the center to pass through the point of contact between the tangent to the circle and to the tangent to the circle, so which means it will be a radius. So the corresponding side, to this radius will be this side. So that's what we have here as R. So now we know that this side is the hypotenuse, okay, and the two legs of the hypotenuse is what we have here as R r. So when we apply Pythagoras theorem in this case, now using Pythagoras rule or Pythagoras theorem, using Pythagoras theorem, okay, using Pythagoras theorem. So we know that h squared equals to a squared plus o squared. That is hypotenuse square equals to adjacent square plus opposite square. So this will be 14 minus r raised to the power of 2. Okay, then the adjacent is r. So we have r raised to the power of 2 and this raised to the power of 2. So now let's expand square of 14 minus r. So this is going to be 196 minus 28r plus r squared equals to 2r squared. Okay, equals to 2r squared. So now let's move everything on the left hand side to the right hand side. Okay, so we're going to have 2r squared minus r squared plus 28r, okay, then minus 196 equals to 0. So this will be 2r squared minus r squared. That will be r squared plus 28r minus 196 equals to 0. Now, we have a quadratic equation. Don't forget, we are looking for the value of r. Another thing again is the value of r must be positive. Okay, in order for us to have a positive solution, okay, the value of r cannot be what? Negative. So to get the value of r, so let's use quadratic formula. So using quadratic formula, okay, using quadratic formula, you know that the quadratic formula will be negative b, r equals to negative b plus or minus the square root of b squared minus 2r squared minus r squared. That will be r squared plus 28r minus 196 equals to 0. Now, we have a quadratic equation. Don't forget, we are looking for the value of r. Another thing again is the value of r must be positive. Okay, in order for us to have a positive solution, okay, the value of r cannot be what? Negative. So to get the value of r, so let's use quadratic formula. So using quadratic formula, okay, using quadratic formula, you know that the quadratic formula will be negative b, r equals to negative b plus or minus the square root of b squared minus 4ac all over what? 2a. So a will be the value of, that's the coefficient of the leading, that's the leading coefficient, which is the what? The coefficient of r squared, and that's 1. Now b is 28, and then c is 196. So we can now plug in the value. So we have r to be equals to minus 28 plus or minus the square root of negative 28 square, okay, no, 28 square, okay, minus 4 multiplied by 1, then multiply by negative 196. So all over 2 multiplied by 1. So this will be r equals to minus 28 plus or minus the square root of, so let's get the value for 28 square. Now for 28 square, that will be 784. That's 784. Then plus, we know that when the minus sign, you know, when they coincide, okay, we're going to have a plus. So what is now 4 multiplied by 196, which is 784, okay? 4 multiplied by 196 is also 784. Okay, so we divide all of that by what? By 2. Okay, now don't forget we have 28 square to be 784. So 784 plus 784, that will be 1568. So r will be minus 28 plus or minus the square root of 1568 divided by 2. 1568 divided by 2. So that r will be equals to negative 28 plus or minus. Now let's get the square root of 1568. Now the square root of 1568 is what we have as 3960, or we have 39.598 divided by 2. Okay, so which means we're going to have negative 28 plus 39.598 over 2, or r equals to negative 28 minus 39.598 over what? Over 2. Now, this one will not be necessary, okay, because it will be negative. We need the value of r over 2, or r equals to negative 28 minus 39.598 over what? Over 2. Now, this one will not be necessary, okay, because it will be negative. We need the value of r, which will be what? Positive. So what we have here is 39.598, okay, minus 28. That will be 39.598 minus 28. Okay, that will be 11.598. So we have 11, okay, 11.598. Then we divide that by 2. So when we divide this value by 2, okay, divide by 2, that will be 5.799. Okay, so we have r to be 5.799, and the unit will be centimeter. Okay, so this is the value of r. This is the value of r. Now remember, we want to calculate also the area of the shaded region. So to calculate the area of the shaded region, this is the first solution. Okay, so to calculate the area of the shaded region, so to calculate the area of the shaded region, the area of the shaded region will be area of the quadrant, okay, minus area of the inscribed circle. And we know that quadrant is 1/4 of a what? A circle. So which means the area of a quadrant. So area of shaded region equals to area of quadrants minus area of circle. Okay, minus area of circle. So now we have area of the quadrant, which is one quarter of, so we have 3.142 multiplied by radius of the quadrant, which is what? 14. So we have 14 raised to the power of 2. 14 raised to the power of 2. We have 14 raised to the power of 2. So minus area of the circle. So area of the circle will be 3.142 multiplied by the radius of the circle. Now that is what we calculated here. So that will be 5.799, okay, raised to the power of 2. So now, in this case, what is 196, which is 14 square, multiplied by 3.142? Now, we're going to have that to be 615 that is 615.832 divided by 4, okay, minus, so we have 3.142 multiplied by 5.799, okay, raised to the power of 2. So that will be 105, okay, 0.66. So now let's get the value for what is 615.832 divided by 4. Okay, now that will be by 3.142. Now we're going to have that to be 615 that is 615.832 divided by 4. Okay, minus, so we have 3.142 multiplied by 5.799, okay, raised to the power of 2. So that will be 105, okay, 0.66. So now let's get the value for what is 615.832 divided by 4. Okay, now that will be, we're going to have that to be 153.958, okay, minus 105.66. So minus 105.66. So what you have as the area of the shaded region, okay, area of shaded region is 48.2 298. Now, we are going to write this to three significant figures. So to three significant figures, so we have the area to be equals to 48.3 square centimeters, and this is the area of the shaded region. Please don't forget to drop your comment in the comment section. Share your thoughts about this question, okay? And let me know where you feel, we need to, how you feel the radius of the shape, of the inscribed circle can be worked out. Bye-bye. I'll see you in the next video.